All right, so I'm going to go over 1.8, which was the section I skipped, right? We went to like 1, 9, 10. And so anyways, we're going back to 8. Okay, so this section is about finding the zeros of rational functions. So just to recap, so far we've done horizontal asymptotes, vertical asymptotes, we've done domain and holes. So last thing we have to do is zeros. Okay, so how you do it is, I'll give you the little steps right here. Basically, you factor top and bottom, right? Numerator and denominator, because you want to make sure you kind of are looking at everything, because that's how we check for vertical asymptotes, it's how we check for holes, right? So factor. The reason we have to factor the top as well is you want to check for holes. So if there is a hole, it can't be a 0. So that's why we're going to check for it. And then the third step, you set the numerator equal to 0. Okay, so for example, this one right off the bat, we can tell, let's do a little review. So we know that it's equal. So the horizontal asymptote would be, y equals 1/2. And let's kind of see if that looks true. Yeah, it does. Looks like at 1/2 there is a horizontal asymptote. Okay. What's something else we can figure out? Let's go ahead and factor. So the top will be x plus 4, x minus 2. The bottom will be 2, x squared plus 2. And you can't factor x squared plus 2. So the domain looks like all real numbers, right? Because that doesn't give you a zero, a vertical asymptote, and that doesn't give you. So the domain is all real numbers, which means there's no vertical asymptotes, and you can see, and there's no holes, right? So you can look at the picture and you can see that there's neither of either one. So how you would find the zeros is you would take the numerator and set it equal to 0. So that would mean we have zeros at -4 and 2. And let's just see if that makes sense. Yep, -4 and 2. So all you do is just set the numerator equal to 0. Okay. The next one I wanted to do was number 3. Okay, let's go through everything again for number 3. Horizontal asymptote, bigger on bottom 0. So y equals 0, and look at that, that checks out. There's a horizontal asymptote at y equals 0. Let's now factor the top and the bottom. So 4, x plus 2 on top. On the bottom, we've got x plus 5, x minus 2. And we're just checking to see if anything cancels out. It didn't, which means there's no holes. So no holes. Let's check on the denominator, right? Remember you set the denominator equal to 0 when you're trying to find the domain. So x cannot equal -5 or 2. Oh, whoops, I forgot my u. Whoops. Oh no, there's a big one. Big eraser, okay. And because it's not a hole, that means that there would be a vertical asymptote at -5 and 2. And you can see that, and that is true. And for the zeros, you set the numerator equal to 0. So I'm going to take that guy, set him equal to 0. 4 does not tell us anything. So x plus 2, that tells us that there's a hole, or sorry, I didn't mean to say hole, a 0 at -2, and that checks out. And another thing I wanted to show you is how to make a sign chart. So if I didn't have this graph over here, we would still be able to find all of this information, right? We've done all of We did domain, we did holes, we did vertical asymptotes, and then I just showed you how to find zeros. So you know how to find all these things. So what you're going to do for your sign chart is you're going to think about your key points. Your key points are going to be vertical asymptotes and zeros and possibly holes. So I'm going to go from left to right. My key points would be -5, 2, and -2. So I'm going to do -5. I'm going to put them in order. -2 and 2. And then I'm going to put, actually I need to leave some more space. Hold on. Over here, I need to put less than -5. Here I need to put, oh, actually I need even more spaces. Oh my goodness. Okay. I'll show you what I'm doing and then it'll make sense. Okay, so I'm gonna do x less than -5. That'll be the first one. And then we're gonna stop at -5. Then we're gonna say -5 between -5 and -2. Stop at -2. And then we're gonna go from -2 to 2. Stop at 2. And then x greater than 2. So basically what we're doing is we're stopping at, go ahead and highlight these. These are our key points. And then what I just did is I just did every area in between the points. So basically we're trying to figure out, like if we didn't have this graph, like you're not going to be given the graph maybe, and you don't have a calculator. So once you figure out your main points, you just have to ask, we're going to ask ourselves like what's happening before, what's happening after, what's happening in between, blah, blah, blah. And that will help us answer some questions. Like for example, let's say it said, where is the function greater than 0? Right? And you were not given a graph. How you'd figure it out is you'd figure out a sign chart. So let's fill in what's happening at those key points. -5 and 2 are vertical asymptotes, so they do not exist. So you can put DNE for does not exist. And at -2, I'll go ahead and draw a line here. At -2, the function is 0, and it will be set up like x and then f of x. Okay, so that's what I have set up so far. Okay, so now here's how you'd figure out what's happening in the sections. So less than -5, I'm going to pick a number less than -5, any number you want. And we're going to go back to our function here. So our original function. I'm going to circle it. Okay. Okay, so a number less than -5, any number you want, -10. Okay, so -10, if I were to put a -10 right there, right where that x is, right, like right there, I'd get -10 plus 2, which is -8, which is a negative number. If I were to put a -10 right there, I'd get -10 plus 5, which is -5, which is a negative number. And if I were to put a -10 right there, I would get another, a -12, which is another negative number. So then I look at this, a negative, negative, and negative. 3 negatives would make a negative. Now let's look between -5 and -2. Let's do -3. If I put a -3 up top, I'd get -1, so negative. -3 on the bottom left would give me positive. -3 on the bottom right would give me a negative. A positive and 2 negatives would give me a positive. Let's take a number between -2 and 2, like 0. 0 up top would give me a positive. 0 on the bottom left would give me a positive. 0 on the bottom right would give me a negative. 2 positives and a negative would give me a negative. X greater than 2, so I'm going to pick 5. 5 on top would give me a positive. 5 on the bottom left would give me a positive. 5 on the bottom right would give me a positive. 3 positives would make a positive. let's just see if that checks out with our current graph. Just since we do have a graph, we can just check to see, make sure I did it right. When x is less than -5, is the graph negative? Yes. Between -5 and -2, is the graph positive? Yes. I'm sorry about my coughing. Between -2 and 2, is the graph negative? Yes. When x is greater than 2, is the graph positive? Yes. So that's how you do a sign chart. So if the question was, when is the graph greater than 0, it would be nope, I'm trying to like write this in. Boom, right there, and boom, right there. So you would say between -5 and -2, and x greater than 2. So that's how the sign chart helps you. You're basically just plugging in values to see if it's positive or negative. Okay. And then, yeah, so the last example I was going to do is number 5. Okay, so let's identify some things from the graph. We have a hole at 4, 5, 6, 7. We have a 0 at -2 and 2. Vertical asymptote looks like at 1, 2, 3, 4. -4. And it looks like there's no horizontal. It looks like there's a slant asymptote. So, none. Slant. Y-intercept look like it's like negative. I don't know. We'll say 0.2. Okay, so look at their table. Look what they have set up. They have -4, because what's happening at -4? That is a vertical asymptote, so does not exist. -2 is a 0, so that means it's a 0 there. 2 is a 0, so there's a 0 there. And at 7, there's a hole, so does not exist. And then they just set up every single interval in between. Okay, so what's happening when it's less than -4? Negative. Between -4 and -2? Positive. Between -2 and 2? Negative. Between 2 and 7? Positive. And between 7 and infinity? Positive. Another thing we could do to practice what we learned before for holes, we could practice limits, holes and vertical asymptotes. So let's review vertical asymptotes. The limit as x approaches -4 from the right, the limit as x approaches -4 from the left, and the limit as x approaches 7 from the right, and the limit as x approaches 7 from the left. So as x approaches -4 from the right, it's heading to infinity. As the limit as x approaches -4 from the left, the graph is heading towards negative infinity. The limit as x approaches 7 from the right, looks like we're approaching, I'm just going to call that 1. I don't know if that's 1, but, you know, based on the graph, that's kind of what I got. heading towards a y value of 1. And as x is approaching 7 from the left, it is approaching a y value of 1. I just wanted to throw that in just to kind of review. We did this together, and then this is what I gave you guys a video on Tuesday, I think. Okay, so I'm going to stop the screen right here so you can pause it. This is what I want you to do for homework. And all you have to do is find the zeros. So remember in the very beginning, I said, here's how to find the zeros. Factor top and bottom, check for holes, because if it's a hole, it's not a 0. Set numerator equal to 0. So that's how you're going to do boom, 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 boom. Okay. And then for 5 and 6, you are just going to do it based on, you know, what I told you about sign charts. So for homework, you're going to have 2 things that I want you to do. Number 1 is doing, well, number 1 through 7 on this paper. And do it on a piece of paper like we normally do homework that you're going to turn in. And then the second thing I want you to do is there's going to be an AP classroom. And it is just 2 questions. So you're going to do that one and that one. And this video, you know, it's not too long, so you should be able to do this in class. But yeah, just 1 through 7. We're going to check it tomorrow. And then the AP classroom, and we'll go over everything tomorrow.